Okay, today's lesson will be our second day talking about 3.1 and 3.2, and this is going to be doing applications of our systems of equations. So we're going to be setting up word problems and then solving algebraically with either substitution or elimination. So we have three word problems that we're going to take a look at. So the first one here, the concession stand is selling hot dogs and hamburgers during a game. At halftime, they sold a total of 78 hot dogs and hamburgers, and they brought in $105.50. How many of each item did they sell if hamburgers sold for $1.50, hot dogs sold for $1.25? Okay, with each of these problems, you want to identify what your variables are. So every problem, we have things that we don't know. Okay, every problem that we're going to look at today will have two things that we don't know. So we will have two variables with each situation. And then once we have those variables, we're going to write our system of equations. So we'll have two equations to go with those two variables. And then we'll choose the best method, either substitution or elimination, to solve. Okay, so when I take a look at this problem, make sure if you're getting stuck on these or you say you're not very good at word problems, read through it and look for the question. The question is going to point out what are the things that we don't know. Okay, the things that we don't know would be how many of each item, trying to circle this, did they sell if hamburgers sold for $1.50 and hot dogs for $1.25? So we don't know how many hamburgers or how many hot dogs. Okay, so those are going to be our variables. So you can choose any variable letter that you want. Sometimes I like to pick letters that would match the things that I'm trying to figure out. So if I used H for the number of hamburgers, I can't use H for the number of hot dogs, unfortunately, but we could use D for the number of hot dogs. You can choose whatever variable you want. You're welcome to just use X and Y every single time, up to you. Some students like changing their letters. They think it's easier to figure out what's happening in the problem, and others don't really care. Okay, so up to you. All right, once we have determined our variables, now we're going to set up our system of equations. So there's going to need to be two equations if I have two variables. So I'm going to take a look and use the information I'm given in the problem. So we have, they sold a total of 78 hot dogs and hamburgers. So that's a big hint. So if I have the number of hamburgers and the number of hot dogs, and I know that total is 78, then I can just take H plus D to get 78, because that's the number of hamburgers plus the number of hot dogs, the total of the 78 items that they sold. Okay, so there's one equation. Now I need to use a second equation, so I'll take a look at the information I haven't used yet. I know they brought in that much money, and I can't just write H plus D equals $105.50, because these aren't the amount of money, it's how many there are. So I have to use the money in this equation as well. Okay, so it's $1.50 for the hamburger. So $1.50 for every hamburger H they sold, plus $1.25 for every hot dog they sold, would give a total of $105.50. Okay, so now I have my two equations. I've used the information I've been given. We've got our two variables, and then we can go ahead and choose either elimination or substitution to solve. So when you're doing your problem yourself, absolutely your choice what you're going to choose. A problem like this, it would be not too difficult to get H or D by themselves in the top equation to use substitution. It also wouldn't be that difficult if I multiply the top equation by something, but I'm going to need to multiply by decimals. So if you don't want to do that, then I would suggest to use substitution. So I'm going to go ahead and do substitution with this one. Let's see, I think I'm going to get, let's get H alone. So I'll subtract D. So then I have H equals 78 minus D. So I'm going to use that equation. I'm going to take 78 minus D and replace H. Okay. So I have 1.5 or $1.50 times the amount of hamburgers, but what am I going to plug in instead is 78 minus D. Because remember, if I know the amount of hamburgers, I would be taking the total 78 minus the amount of hot dogs to have the amount of hamburgers. Okay, so sometimes the word problems can start to make more sense as to what's happening with the math. Maybe, maybe not. Okay, I'll go ahead and distribute here. So 117 minus 150D plus 1.25D would equal $105.50. If I combine my like terms, I'm going to have negative 1.5D plus 1.25D would be negative 0.25D. And then I'll go ahead and subtract 117 to the other side. So then that would be equal to negative 11.5. And I can divide both sides by negative 0.25. So then I'll find the amount of hot dogs to be 46. Okay, so from here, I know there are 46 hot dogs. If I know the amount of hot dogs is 46, I can go ahead and use my little equation. 78 minus 46 would mean there are 32 hamburgers. In my final answer. Okay. All right, we'll go ahead and take a look at the second example. So Mr. Doyle bought 2 pounds of cheddar cheese and 3 pounds of chicken loaf, and he paid $26.35. Mrs. Doyle paid $18.35 for 1.5 pounds of cheese and 2 pounds of chicken loaf. Here is our question, right? That leads us to our variables. What was the price per pound of each item? Those are the things that we don't know. We've got 2 items that we don't know. So first thing I'm going to do is set up my 2 variables. Once again, you can use whatever letters you would like, or you can use letters that go with the things that we have in the problem. Once again, it's not going to be that great because they start with the same letter. But if I use C, and I'm using that to represent cheese, I'm not just going to write C equals cheese because I want to be as specific as possible so it makes sense when I set up my problem. C is the price per pound. Price per pound of cheese. Okay. The other variable I got is chicken. So I'm going to, hi. Is that, okay. All right, we're back. So if you wanted to use something like L for the loaf, you can. I'm going to use a cursive L so it doesn't look like a 1. All right, so now I have my 2 variables. I'm going to go ahead and take a look through the information to see how I can use my C and my L and set up 2 equations that I can solve. So I have 2 situations happening. I have Mr. Doyle who purchased some stuff, and I've got Mrs. Doyle who purchased some stuff. And so Mr. Doyle is going to be in one equation, and Mrs. Doyle will be in the other equation. Okay, so these equations will have, since they both have cheese and chicken loaf in their situations. So I've got Mr. Doyle bought 2 pounds of the cheddar cheese, plus he also bought 3 pounds of the chicken loaf, and he paid $26.35. Okay. Mrs. Doyle paid $18.35, and she bought 1.5 pounds of cheese and 2 pounds of the chicken loaf. Okay. So then I take a look at these two problems. I decide if I'm going to do elimination or substitution. This one is going to be a little bit messier if you try to get a variable by itself, because we're going to have to do some dividing. So we're going to get a little bit more decimals or fractions. So my suggestion would be to do elimination in this problem, but ultimately it'll be up to you. I think I'm going to try to eliminate L, so I can multiply the top equation by 2, the bottom equation by 3, so that I'll get a 6 in front of those, but I want one of them to be negative, so it doesn't matter which one's negative, so I'll go ahead and throw that on top. Okay, I'm going to rewrite those two equations. So I'll have negative 4c minus 6l would equal negative 5270. My second equation, multiplying that by 3, give me 4.5c plus 6l equals 55.05. Okay, now when I take a look at these and I'm ready to add them together, I should see that I'll be able to eliminate the L's. So I multiplied by something that was a good choice. Okay, so then when I go and add these together, negative 4c plus 4.5c would be 0.5c. Those would be eliminated. I've canceled out my chicken loaf. And then negative 5270 plus 55.05 would come out to be 2.35. Divide both sides by 0.5. And C would be 4.7. Okay, something that's nice with word problems actually can give you a better idea if you're doing things correctly. Like let's say I got a negative answer, it won't make sense for me to have a negative cheese or chicken. Also, I've got 4.7, so some students might get confused by that, but take a look at why I labeled these more specifically. So when I'm done, I know what this is representing. It's not 4.7 pounds of cheese, okay? It is $4.70 per pound of cheese. Okay, so that's another reason why I just don't write cheese. So you don't say 4.7 cheddar cheese. Okay, we need to know what that number is representing. We have a situation. We need to label it. So, all right, then I need to go ahead and figure out the chicken loaf. So to do so, you're going to have to take your 4.7 for C and plug it back into any of our equations we got here. I'll go ahead and do it off on the side. I'll use this one up top. So I've got 2 times 4.7 plus 3L equals 2635. 2 times 4.7 be 9.4. I'll need to subtract 9.4 from both sides. So then 3L would equal 16.95, and then I'll divide by 3. Okay, so then L would come out to be $5.65 per pound of the chicken loaf. For our final answers. All right, we got one more problem we're going to set up here. So these ones sometimes confuse students, these ones with the percentages and these different solutions. You will have one like this on your homework. So I did want to make sure we go through one example here together. So a scientist wants to make 6 milliliters of a 30% sulfuric acid solution. The solution is to be made from a combination of 20% sulfuric acid and 50% sulfuric acid. So here's our question is how many milliliters of each solution must be combined to make the 30% solution? Okay, so our two different solutions are the 20% and the 50%. Okay, so in this case, if you just wanted to use an X and a Y, I'm good with that because our X and our Y are representing the same thing, but it's different percentages of that solution. So my X can represent my 20, or I'll be specific, the number of milliliters for that 20% solution, and then the number of milliliters for that 50% solution. Okay, so we're going to use X and Y then to set up our two equations. So if we're wanting to make 6 milliliters, okay, and these represent the number of milliliters, I can add X and Y together to get the total of 6. Okay, very typical first equation in these solution problems with all these percentages. Okay, the next one needs to have all of the percentages. Okay, so I need 20% of my X. So if I'm writing as a decimal, 20% would be 0.20 times X. Plus, I would need 50% of the Y, because that's the one at that 50%. So 0.50 Y, or I could just do 0.5 Y and 0.2X, that's fine. Equals, now I have a lot of students that will equal it to 6. Okay, you're going to get a no solution if you equal it to 6 because you have the same exact problems, but you change in front of X and Y and you have it equal to the same thing. Okay, so we can't do that. We have to take 30% of 6. So 0.30 times 6. Or you can write that then as 1.8. Okay. All right, so we have our two equations set up. The first one is just all straight milliliters. This amount of milliliters plus that amount of milliliters has to give me 6 milliliters. The next one is all the percentages. So 20% of this plus 50% of that is going to give me the 1.8 milliliters because that's 30% of the 6 milliliters. Okay, so very similar setup for the one for your homework. So use this example to help you out. So I can go ahead and use substitution or elimination here. Both would be fine. Pretty easy to get X or Y by itself. Not too bad to multiply either. I think I'm actually going to try elimination this time. And I can multiply by 0.5 pretty easily in my head. So I'll multiply by 0.5 to eliminate this 0.5y, but I will need it to be negative. So I'm going to go ahead and write it over here. I get 0.5x minus 0.5y, and then half of 6 would be 3, but it needs to be a negative 3. And then I'll rewrite my bottom equation again. So 0.2x plus 0.5y, and 0.3 times 6 is 1.8. Okay, combine these, so negative 0.3x. Y's are eliminated, and negative 3 plus 1.8 would be a negative 1.2. Divide both sides by negative 0.3. Dividing a negative by a negative, so we're going to get a positive answer, which is good because it wouldn't make sense if I didn't. And so then X would be 4. So that means 4 milliliters. X was the 20%. So of the 20% solution. And if they had to add up to 6, and X is 4, Y must be 2. You can always go back and plug those back into the second equation as well and make sure that that makes sense to be confident in your final answer. Okay, those are our 3 problems for our notes today. Good luck with your homework.